Hello everyone, welcome to my YouTube channel, that is Bishas Engineering School. In this class, we are going to know about colloids. In the previous class, we knew about the purification of colloids. In this class, we are going to know about the properties of colloids. Let's know about the properties of colloids. That is the properties. Before starting the class, I want to say that if you like my video, please comment, comment and subscribe. And let's start the class. That is properties of colloids. From the very first class, I started to say that colloid is very important for us. We use colloids in everyday life. We eat milk every day. We use a cream. That everything is colloid. So we must have to know the properties of colloids. So watch the video very carefully. You will understand all and every property if you watch the video very much attentively. So let's start the properties of colloids. That is the properties. We know the three properties, that is optical properties, kinetic properties and electric properties. So let's start that. That is the first one is optical properties. Optical properties means that the colloids behaves in optical medium. And the second one is kinetic properties. And the third and the last one is electrical properties. So before starting this, I want to say that in the optical properties we will learn about the only Tyndall effect. In kinetic properties we will learn Brownian motion. In the electrical properties we will learn the positive, negative colloids, detection of charge, electrophoresis, electroosmosis, and the last is zeta potential. So let's start the class, and we will start this with the optical properties, that is Tyndall effect. Let's start with this Tyndall effect. So suppose we have taken a container. In two container, in one container there is a solution of sodium chloride and there is a solution of milk. We know that sodium chloride is a true solution and milk is a colloidal solution. So we have taken two container. That is, the first one is NaCl solution and the second one is colloidal solution. So we will learn about the Tyndall effect with only these two containers. That is, we have taken a light sources right here, and the light is emitting the visible ray, and the path is, that is the path of the light. So when we pass light in a true solution, we know that sodium chloride solution is a true solution. So when we pass light in a true solution, we won't find a path in the solution. That is, we won't find in the path in the solution, but the light will be emit in this position. The light passes in the sodium chloride container, but we won't find the path from where the light is passing. But if we take the colloidal solution, we will find that the light is going, the light ray is going, the light ray in true solution we won't find any path of light ray, but in colloidal solution we will find the path of light ray, and the light will be emit in the other portion of the container. So what is Tyndall effect? The Tyndall effect says that if we take a light sources in the portion, we will find that the light is going, and we will find the path of light. But if we take a true solution container, we won't find a path, but the light will emit on the other side of the container. But if we take a colloidal solution, we will find a path in the solution, and the light will go in the other side of the container. That is Tyndall effect. That is the Tyndall effect. It is the result of Tyndall effect. The colloidal solution only shows the Tyndall effect. So what is the reason why the colloidal solution shows the Tyndall effect? The reason is that the colloidal particle is pretty much larger than the true solution. That we know that true solution is 0.1 nanometer to 1 nanometer, but the colloidal solution is 1 nanometer to 10 to the power 3 nanometer. So as the particle is pretty much large, there is a scattering of light. So as the scattering of light is occurred, we will find the path. That is the path of light. That is Tyndall effect. So the Tyndall effect we can write here that when we take true solution and colloidal solution, and if we pass light we won't find a path of light in the true solution, but due to scattering of light we will find a path in the colloidal solution, and that is Tyndall effect. So the summary of Tyndall effect is that the colloidal solution shows Tyndall effect, but the true solution don't show Tyndall effect. So if we summarize the Tyndall effect, that is, if we have taken two containers, one container is in true solution and the other container is colloidal solution. We have given a sources of light in the other side of the container, the light passes in the true solution, we will find a path. But when the light passes in the colloidal solution, we will find a path. Why we find the path? Because the colloidal size is 1 nanometer to 10 to the power 3 nanometer. That means the colloidal particle is pretty much stronger, pretty much larger than the true solution. That's why there is a scattering of light, and due to the scattering of light, we will find the path, and that is, and the effect is called the Tyndall effect. I hope it is clear for everyone. So we have completed very fairly the optical property, that is Tyndall effect. So if we concentrate, I hope it is very much easier to learn this. And the second one, we know that is kinetic property. We will learn the Brownian motion in the kinetic property. We will learn the Brownian motion. What is the Brownian motion? We have to learn. That is, we have taken a container. In this container, there is a colloidal solution. There is a colloidal solution. So we know that colloidal solution is made of, the colloidal particle, that is dispersed phase and the electrolytes. We also know that when we learned about the purification of colloids, we knew that the colloidal particle size is pretty much larger than the electrolytes. So the colloidal solution is colloidal particle plus electrolytes. So the Brownian motion, from the Brownian motion we have learned the path of motion of the colloidal particle. That is, the electrolytes is very much smaller. Suppose we have taken a container in that size. There is colloids plus electrolytes, and you have to imagine something, that is, suppose you are standing in a busy path. You are just standing, you are not doing anything in a busy path. A lot of people, suppose you are standing in a movement. In a movement, the thousands of people arise there. So if we stand there, you will be go that side or that side or that side. That is because the in the movement the people are giving you energy, and by their energy you are going in the zigzag line. That is, it is not your energy. You are going in the different direction by the energy of other people. So the colloidal particles takes energy colloidal particle takes energy from the electrolytes. By taking energy from the electrolytes, the colloidal particle run in the solution in a zigzag motion. That is, the colloidal particle, suppose that is the colloidal particle and that is the electrolytes. From the electrolytes, the colloidal particle is taking energy. By taking energy, the motion of the colloidal particle will be that, like that, zigzag motion. That is zigzag motion. So the Brownian motion states that the movement of colloidal particle will be the zigzag motion. From where the colloidal particle is getting energy? The colloidal particle is getting energy from the small electrolytes. You will think about the movement, that you are standing in a movement, but from the due to presence of lot of people, you are going in the different sides. That it is not by your energy, you are getting energy from the others people. So the colloidal particle is getting energy from the electrolytes, and the motion is zigzag motion. That is the Brownian motion. So I hope you have learned about the optical properties and the kinetic properties very clearly. If you have any query or any problem, please write in the comment section. I must answer it. So we'll learn in the electrical property in the next video. Till then, thank you everyone, and if you like my video, please like, comment and subscribe. So till then, thank you everyone.